Hello everyone, hope you're all doing alright. Yeah, sorry that I couldn't be in. I'm trying my best to get back in, but yeah. Okay, so integration. Up to now we've done sub-chapters A, B, C, D. So we're going to start on E, okay? I'll go through that in a minute though. Firstly, I want you to do the starter. You're going to need this for part of this lesson. So have a look at these questions and have a quick go. You look back at your notes if you need to. Pause it please. Okay, so just to make sure you know what you're doing, implicit differentiation is when you just differentiate an equation when it's just given to you. So let's have a look at the first one. So x squared equals y cubed. So we're trying to find dy by dx. So we want to differentiate with respect to x. So x squared differentiated with respect to x is 2x. Y cubed differentiated with respect to x. Now, we're not differentiating the correct letter, are we? The way we do it is ignore the fact if it's different and just differentiate normally. So this differentiated is 3y squared. However, to correct the fact if it's not the correct letter, multiply by the letter you're using by the one you actually want. So this is our differentiated equation. However, we want to find dy by dx, so we divide both sides by the 3y squared. So the equation you should have got for your differential is that. Okay, now I'm not going to go through the rest, I'm just going to show you the answers. Okay, so all of these are your differentials. So the first one, dy by dx equals this, second one, dy by dx equals this, and so on. Okay, so if you need to, pause the video and mark your work. I'm going to carry on in a moment. Okay, so just because I know you'll be asking at some point in the lesson, here's all of the questions that I expect you to do from the exercises. Okay, I'll put them on to show my homework, but you can make a note of them now if you want. Okay, this is all of the rest of chapter 11. Okay, so, oh, by the way, trapezium rule here, Mr. Reynolds has done that with you. So, yeah, I'll let him choose the questions because I haven't actually done trapezium rule with you. Okay, so starting with chapter 11E, so substitution, integration by substitution. If you think back to GCSE, substitution is when you swap a letter for a number, isn't it? Yeah, so you swap a letter for a number, let's say 3x plus 2, and you were given that x equals 2, so you sub 2 into there, so 6 plus 2 is 8. Okay, so it's the same sort of idea with this. Okay, so same idea, however, obviously more difficult because this is A level. So when it says substitution, we want to substitute in something for the x's. Okay, everything with regards to x needs to disappear. Okay, now when I say with regards to x, there's almost everything in here is with regards to x. So we need to swap the x's, we need to swap this dx, and we need to swap the limits because these are actually x terms, aren't they? This is x equals 2, this is x equals 4. So substitution, we need to get rid of the limits, all of the x's, and this dx. Okay, it'll make sense in a moment with what you get rid of it with, but you need to understand the fact of substitution, you get rid of everything with regards to x. Okay, so as I've said, we need to change those three things in every substitution question. Okay, unless if you're not given limits. Okay, if you're not given limits, there's nothing to change. Okay, so actual questions. So first example, use the substitution u equals 2x plus 5 to find the integral of x, the square root of 2x plus 5 with regards to x. So, as I've said, we want to swap three things: all of the x's, the dx, and the limits. For this example, though, there are no limits, as I've said, so we just need to swap the x's and the dx. Now, in this example, it's nice because it's given you a substitution. It won't always give you the substitution, however, in most cases it will. Now, it's pretty simple, to be honest, substitution is. In the question, you're given x's, you want to swap it for u's. So here, we have x's, we want to swap them for u's. So now x, we need to rearrange this to get x, so we can substitute it in. Okay, so if you, what's it called? Oh, my mind's gone blank. Rearrange the word. Rearrange this to get x, so you'd get x equals a half lots of u minus 5. Okay, so we can substitute in that x there. Also notice the thing inside of the square root is just u, so our integral would just be x, so half u minus 5 square root of u. Okay, the thing inside of the square root is just u, isn't it? So we want to multiply that by the square root of u. Now we don't need to do it all together. I'm going to put the dx on the end for now. This dx we need to change though, don't we? Okay, so the dx, let's focus on that now. So dx is made by differentiating something, isn't it? Differentiating with respect to x. So look back at your substitution equation, u equals 2x plus 5. If we differentiate this with respect to x, so du by dx, we get 2. So if you rearrange this, you can get dx equals a half du, and now you can just substitute that straight in. So this integral becomes a half u minus 5 lots of, I'm going to write u to the half instead of the square root of u, and then instead of dx we have a half du. Okay, now this still doesn't look very nice, so let's tidy it up. So all of this is times together, isn't it? So the half and the half, you can combine them to become a quarter. This du just stays on the end as normal, and then these, you can just expand the brackets, can't you? U times u to the half, that's got a power of 1 really, hasn't it? So add the powers, you get u to the power of 3 over 2. And then minus 5 times it, minus 5u to the power of a half. Okay, now remember, this quarter is times by all of it, so I've left the brackets in. Okay, now, as I've said to you in the past, when you have a constant, you can pull it out of the integral sign. Okay, so this is just the same as a quarter of the integral of u to the power of 3 over 2 minus 5u to the power of a half with respect to u. Now this is just a standard integral, isn't it? So this integrated is a quarter, lots of. This is just a letter with a power, isn't it? So you can increase the power by 1, divide by the new power. So increase the power by 1, you get 5 over 2. Divide by 5 over 2, you get 2/5. And then u to the power of 5 over 2, increase the power by 1. Same idea here. So it's minus, increase a half by 1, you get 3 over 2. Divide 5 by 3 over 2. So it's 10 over 3. Let me just double check that. Yep. And then u, increase the power by 1, 3 over 2. Close the brackets, stick the c on the end. Okay, because we haven't got limits, we've got nothing else to do, have we? So our answer is just multiply this out. So 1/10 u to the power of 5 over 2 minus 5 over 6 u to the power of 3 over 2 plus c. Okay, now Are we finished? No. In the question it says use the substitution this to find the answer to this integral. In the integral you've got x's. In our answer we've got u's. So do not forget, well, this is your first example, but you can't forget that you need to actually substitute back in x for u. So our answer actually is 1 over 10 brackets 2x plus 5 to the power of 5 over 2. That's a 2, not a whatever that looks like, minus 5 over 6 brackets 2x plus 5. Sorry that it's getting very small in the corner. 3 over 2 plus c. Okay. Now, substitution is one of the easier integration topics just because most of the time it gives you the substitution. Okay, so when it gives you the substitution, use the substitution to rearrange to find what you're subbing in for x or whatever letter. Differentiate your given substitution to find what dx is. Sub all of that in, work out the integration, and then sub your original variable back in for your answer. Okay, so there's a nicer written answer. Okay, so if you need to pause it, go ahead. However, there's a nicer version. Okay, so this is the same example as what you've just seen. Okay, it's identical. However, here it gives you u squared equals 2x plus 5. Okay, now it's given you a slightly different substitution. However, this one, it works out nicer. Okay, it says here, when a root is involved, it makes things much tidier if we use u squared. Now let's do the thing all over again. Okay, so we're working with the integral of x square root of 2x plus 5 dx. We're swapping x's for u's. So u squared is 2x plus 5. So we can swap this for u squared. So we've got the square root of u squared. X, we need to substitute in what x is. Now this time, x is going to be a half of u squared minus 5. Okay, so x is just this. So we've got a half of u squared minus 5 times by the square root of u squared, and now dx, which we're now going to swap. Okay, now dx, so we need to differentiate this. Now, we're differentiating with respect to x, aren't we? So u squared differentiated, this is where the starter comes in. We need to differentiate u squared with respect to x. Now, because it's u and not x, just differentiate it normally. What's u squared differentiated? 2u. But because we're differentiating with respect to x, we need to multiply by du by dx. Okay? Implicit differentiation, as it says in the title. Okay? And now, right-hand side, 2x differentiated with respect to x is just 2, 5 disappears. Now, let's rearrange it for dx. So dx is equal to u du. Yeah, multiply the dux up, divide by the 2, so dx equals u du. So our integral is actually a half lots of u squared minus 5. Square root of u squared is just u, and dx is u du. So this becomes, I'm going to pull the half out because it's just a constant. The integral of u squared, this is the same as u squared as well, isn't it? So u squared times u squared is u to the power of 4. 5 times u squared is just 5u squared, obviously. Then du. Integrate that, we get a half square brackets a fifth, u to the power of 5 minus 5 over 3 u to the power of 3 plus c on the end. Now, we're almost finished. Expand the brackets. Now, u, we don't want it, do we? We want x. So, we need to substitute u back in. However, we've got u squared. So what we need to actually do is square root this. So we know that u squared is 2x plus 5. So u is the square root of this thing. I don't really like square root signs, so I'm going to do a power of a half. So our final answer, substitute this in. So our answer is a tenth, lots of 2x plus 5, a half times 5, index laws. Same idea here, so minus 5 over 6, 2x plus 5, a half times 3, 3 over 2, plus c. Now I can't go back on this, however, if you check with the previous answer, it's identical. Okay, so the purpose of me doing all of that was this substitution you started with. Now, as I've said, most of the time you're given the substitution, in which case you need to know how to use the substitution. If you're given a u squared, you need to use implicit differentiation. Where was it? Here. So if you're given a u squared, to find dx, you need to use implicit differentiation. However, you don't get any halves in your actual integration itself, so it is slightly tidier. Okay? Okie dokie, so carrying on. There's a neater way of it written. If you want to pause it, go ahead, but there's no need. Okay, so substitutions. In most cases, you're given the substitution, as it says up here. Okay, you're given the substitution for most of these questions. Sometimes you might not, though. And in step. So you two who do step, you'll need to do these. So, sensible substitutions. You need to be able to spot what substitution to use. Now, in most cases, it's very, very easy to spot. This first one, the bit that makes this nasty, is the bit inside the square root. So your substitution would just be this. Okay? I would click this question mark thing, but it just doesn't disappear. Same idea with the next one. Okay, now the e, if this was just e to the x, this would be pretty nice, wouldn't it? Because e to the x integrated is just e to the x. So the bit that makes this nasty is actually the x squared. So if you substitute out the x squared for u, it'd just be e to the u, and this dx might disappear when you differentiate x squared. Next one, the fact that this is a fraction makes it nasty. So make the bottom nice. Okay, so substitute out the bottom because the fraction's the bit that makes it very, very nasty. Then the last one, as I've said, like this one, the second one that is, this one, the power, if this was just e to the x, it would be nice, wouldn't it? So if we substitute u for the power, this would be a pretty nice question. Okay, so there are your substitutions. Now, as I've said, when you're given a square root, your substitution should be the thing inside of the square root. It makes it nicer. When you've got e to the power of something, your power is the thing you substitute. And when you've got a fraction, in most cases, you go for the bottom of the fraction. Okay, carrying on. So, Another example, if you want to try any of these questions yourself, just ask for the video to be paused. However, I have got a couple of questions for you to try yourself, specifically made for you. Okay, so this one, I'll go through it. So, use the substitution u equals sine x plus 1 to find this integral. Notice how it's the inside of the brackets, which is the substitution. That is the case most of the time. So we want to swap every single x here for a u. Okay, so you can see straight away the brackets is just going to be u cubed. So I'm going to write that. So u cubed. We know that sine x is u minus 1. Cos x, if you don't know what to do with it, just leave it there for the moment. Come back to it in a minute. Then dx, we also don't know what we're doing. Okay, so we've done the easy bits. Now let's start with the cos x. So u equals sine x plus 1. So we know that sine x is u minus 1, as we've already said. Now how can we work out what cos x is from sine x? Well, let's pause there for a second. Okay, let's look at the dx. To find the dx, we need to differentiate this, don't we? So du by dx equals, what is this differentiated? Well, sine x differentiated is cos x, plus 1 disappears. Now if you look at this, this is where substitution becomes quite nice when you're doing the questions. Dx is going to be equal to du over cos x. And that is going to be the case in a lot of these questions. It will be quite nice and it cancels out some of these nasty bits. So here, I'm going to leave the cos x there for a moment. Sorry for the bad handwriting. U minus 1 u cubed, dx is the same as du over cos x, and the cos x is cancel. Okay, so in summary, don't rush to swap everything. In a lot of cases, it actually works out nicer to start with your differential to see if anything disappears. Okay, so here, yes, do the easy ones, but this cos x is quite nasty because, well, you can't get cos x from this very nicely. So focus on the differential, work out what you need to substitute in, and see if the stuff cancels. Now this integration is actually quite nice now. U times u to the power 3 is u to the power 4. U to the power 3 times 1 is u to the power 3. We're integrating with respect to u, so our answer 1/5 u to the power 5 minus 1/4 u to the power 4 plus c. Now again, remember, this has got u's, we want x's, so substitute u back in. So our answer is 1/5 sine x plus 1 to the power 5 minus 1/4 sine x plus 1 to the power 4 plus c. Okay, so I don't think there's anything else to say about that example. Nope. I'll just say the start bit again. So when you're first coming across the question, swap anything which looks easy. The thing in the brackets is just u. This sine x is just u minus 1. And the cos x and the dx aren't easy, so leave them there. Because this cos x isn't easy, start with a dx. So to find dx, differentiate your starting substitution equation. So if you differentiate this, du by dx is equal to sine x differentiated with cos x. Rearrange for dx. Okay, now stick dx into your integration. and then you'll see the cos x's cancel, and then you can just do the rest easily. Okay, and there's a nicer written version. Okay, so as I said, here's one for you to try yourself if you'd like. So pause the video if you'd like to try this. If you don't want to try it, then obviously you can save the time and just look at the answer in a minute. However, I do recommend you try one for yourself. Okay, so have a go at this one. Pause the video, please, and use this hint. Okay, the hint's important. Just pause the video, please. Okie dokie. Now, I've just realised that the answer was on the previous slide and I can't go backwards. So, could you please, whoever's working a computer, just go back and try and pause it very, very quickly on the slide before this one. If you're not able, actually, I'll put a copy of the slide in the shared area for you to have a look at if you can't get back on that slide. Okay, so carrying on. As I said originally, integration by substitution, there's three things you need to change. X's, dx, limits. Up to now, we haven't had limits. This one, on the other hand, does. So, firstly, this question, nasty, because it doesn't give you a substitution. Now, as I've said before, you need to be able to see what the substitution is. In this case, you've got a square root, so the thing inside of the square root is your substitution. Okay? Now, we just need to do the rest, okay? So swap all the x's. So this thing inside would become u, wouldn't it? So it's the square root of u. However, there's two choices here. You can either do square root of u, or you could do u squared here, which means that this would just be u with the square root. It's up to you. I'm going to stick with u just because I don't see why not, to be honest. But you could also use u squared if you remember back to a couple of slides ago. Okay, so this is square root of u. Cos x, well, we've got the same problem as just cos x and sin x. You'll have to get square roots and stuff, so let's just leave it as cos x for the moment. It's not very nice to swap. We're integrating. Dx, we haven't found what it is yet. And 0 and pi over 2. Now let's focus on that. If x is 0, so x is 0, what's u going to be? Well, u is going to be 1 plus sine of 0. Sine of 0 is 0, so when x is 0, u is 1. When x is pi over 2, u is going to be 1 plus sine of pi over 2. Sine of pi over 2 is 1, so u is 2. Okay, so x is 0 is the smaller limit, so that's going to become the 1. Pi over 2 is the bigger limit, so that one's going to become 2. So we've swapped the limits. We haven't swapped all of the x's yet, and we haven't swapped the dx. So let's focus on the dx next, because the cos x isn't easy. So to swap dx, differentiate your substitution equation. So du by dx equals cos x. And now dx, like the previous example, dx is going to be du divided by cos x. Okay? So now let's focus back on this. So integral of 1 and 2 of cos x square root of u, dx is du over cos x. Now cos x's cancel. So this is just the same as the integral between 1 and 2 of u to the power of a half du. Again, here, square root of u is just u to the half. Integrate that, you get increase the power by 1, divide by it, 2/3 u to the power of 3/2. And because it's definite integration, we don't need the plus c, and we just need the limits. Now, because these are values of u, we can just sub them straight in. If these were values of x, we'd need to swap it to x first. However, because we've changed the limits to u's, we can just say when u is 2, when u is 2, the value of that's going to be that. When u is 1, the value of this integrand is this. And when you're finding the difference between the two, you subtract, so you need to just work that out to get the answer. Okay? Now, I'm going to grab my calculator. So it's 2/3 times 2 to the power of 3/2 minus 2/3 times 1. See your answer, minus 2 plus 4√2 all over 3. Okay? Or minus 2/3 plus 4/3√2, it's however you want to say it. Okay? So, that's definite integration. Okay? The only difference between definite and indefinite is the limits. Okay? And remember to change the limits. Okay, and all that's happened here is they've factorized out the 2/3. Okay, again, one for you to try if you'd like. So pause the video if you'd like to try it. Otherwise, just carry on and I'll show you the answer. Okay, answer is there. Okie dokie. So that is it, I think. Yep, that's it for integration by substitution. Now on to integration by parts. Okay, so somebody just pulled up my door, give me 1 second. Sorry, I can't pause the video. Okay, so that's integration by substitution. Integration by parts. Now, integration by parts is when you have two things multiplied together. Okay, so here we've got a product. It's kind of like the integration version of product rule. Okay, integration by parts is when you have two parts multiplied together. Okay, so substitution is when you're given a substitution or it tells you to use substitution. Integration by parts is when you have two parts multiplied together. Okay, now integration by parts, it's simple in the sense of you're given a formula, this one. Okay, so this formula is the one you use. So if you look at what you're given here, integration of u dv by dx dx. So there's two things multiplied together, a u and a dv by dx. The difficult-ish bit of integration by parts is choosing which bit to be u and which bit to be dv by dx. Okay, now in this question up here, we've got an x and a cos x. Okay, we need to choose out of these two things that are multiplied together, which is going to be u and which is going to be dv by dx. So, if you look up here in this formula, we start with a u and we need to find du by dx. So we need to differentiate the one thing, and the dv by dx, we end up with v's, so we need to integrate the other thing. Now, with integration by parts, the one that you differentiate, so u, needs to be the one that disappears. If you differentiate x, it becomes 1. 1 is nicer than x, isn't it? Always pick your x term, so x, x squared, x cubed, whatever, to be the one you differentiate. dv by dx is just then the other one. Okay, so u in this formula, pick it to be the one like x, the one that will disappear when you differentiate it. dv by dx, just choose it to be the other one. Now, here we've got a u and a v, so we need to integrate this to find v. And here we've got a v and a du by dx, so we need to differentiate u to get dx. Okay, so notice how I've laid this out. Eventually, you need to actually find u, v, du by dx, and dv by dx, all 4 of them. Okay, and you start with a u in here, and you start with a dv by dx in here. Okay, now you know u is x, so du by dx, differentiate x, you get 1. dv by dx is cos x, so v, integrate cos x, you get sin x. Okay, when you integrate cos, it doesn't change sign. Now, integration by parts is relatively simple from now on, purely because it's a formula. Substitute into the formula. So u is x, dv by dx is cos x. So as you'd expect, there's the question, yeah, equals uv, u times v, x sin x, minus the integral of v sin x times du by dx, which is 1. So 1 times sin x dx. Now that's equal to x sin x, doesn't change, minus the integral 1 times sin x is sin x with respect to x. This integral is relatively straightforward, isn't it? The integral of sin x. So x sin x, take away sin x integrated. When you integrate sine, it changes sign. So this will become minus cos x. Then we need plus on the end because we've integrated. So our answer, x sin x, minus and a minus makes a plus, cos x plus c. And there's our answer. Okay, so it's actually a lot nicer looking than integration by substitution, and it is because there's less to remember. It's literally just a formula. And there's a nicer version. Okay, so another example. Now, I'm pretty certain the formula is in your formula booklet. I don't have a formula booklet with me, so can one of you please check if it's in your formula booklet? I'm almost certain it is. Okay, so the formula, off the top of my head, u dv by dx with respect to x equals uv minus the integral of v du dx with respect to x again. Okay, so u and dv by dx. We need to choose one to differentiate and one to integrate. Now, in the previous example I said, always pick your x squared to be the thing that you differentiate. Now, if we were to do that, we would have to integrate a natural log of x. Have I ever told you anything about integrating natural log? If you've said yes, you're wrong, because I haven't. Okay? You can't integrate natural log. Okay? There is no integrand for it. You don't know what the answer is. You can't integrate it. So, natural log, if there's ever a natural log, that's the one you differentiate. Otherwise, go for the x's. Okay? So, I'm going to tidy this up because I put that in the wrong place. So, if you're ever picking what to differentiate, if there's a natural log, differentiate it. If there isn't a natural log, pick the other thing. Okay? So, as I've said, we've got u, we've got dv dx, we need a du dx, and we need v. So let's work them all out. U is natural log, so du dx is going to be this differentiated. Now, obviously, you can discuss it between yourselves if you want. What is the differential of natural log? 1 over x. The integral of x squared, a third of x cubed. Now, sub it all into your formula. U dv dx, so u times dv by dx. Oh, is that right? Yep, sorry, yep, having a minute. So there's the question, u dv dx, and we're trying to work it out. So uv, so a third x cubed times natural log of x. I always put any sort of polynomial, so x cubed, x squareds, in front of a natural log. Otherwise it'll look a bit strange. Natural log times whatever afterwards, it looks weird. Okay, stick the minus in. We're integrating v du dx. V is a third of x cubed. Du dx is 1 over x with respect to x. So next line, this thing at the front never changes. Minus the integral, a third of x cubed times 1 over x is a third of x squared, and we're integrating that with respect to x. So again, this first bit doesn't change. Minus, integrate this, increase the power by 1, divide by the new power, a ninth of x cubed plus c. So there's our answer. Okay? So, I'll go back to this start bit because the start bit is the hard bit. When you're choosing what to differentiate, always pick natural log. If there isn't a natural log, pick your polynomial term. Okay? So when choosing what to differentiate, pick the natural log. If there isn't a natural log, go for the thing that decreases in power. Okay, there's a nicer version of the answer written out. Now, x squared e to the x. Notice how in the title it gives you what the whole point of the example is. Integration by parts twice. Now, if you think about this in advance, you'll be able to think of why we have to do it twice. However, let's just get stuck in. So, our formula is u dv dx with respect to x equals uv minus the integral of v du dx with respect to x. So we need to choose a u and we need to choose a dv by dx. Now, follow what I said last time. If there's a natural log, choose that to differentiate. If there isn't a natural log, choose the thing with the decrease in power. There isn't a natural log, so choose the polynomial thing, the x squared. So the thing we integrate is e to the x. So du by dx and v, we need to work them out to sub them into the formula. So this differentiated is 2x, this integrated stays the same. So integral of x squared e to the x dx is equal to uv, so uv x squared e to the x minus the integral of v du dx, v du dx, so 2x e to the x dx. I'm going to straighten that x up, there you go. Okay, so we've gone from having an integral with an x squared to an integral with an x. So it's done something, it's made it slightly nicer. It's gone from a quadratic to a linear x. However, as it says, we need to actually do integration by parts twice. Okay, so we need to do it all over again. We need to pick what u is, we need to pick what dv by dx is. Okay, so u, again, pick your polynomial bit. And we want to integrate e to the x again. So du by dx is 1, v is e to the x. Now, if you notice I've ignored this 2, that's purely because I can just do this. Okay, and I'm going to do that because it makes it a bit nicer. Okay, so this 2, I've just brought it out the front of the integral, and then the 2 can just be dissipated from here. So I'm going to give myself a bit more space. So this is equal to x squared e to the x, hasn't changed, minus 2, then this integration, which we're working out at the moment. So stick a massive square bracket there. So integrate x e to the x, so uv x e to the x minus the integral of v du dx. V is e to the x, du dx is e to the x, is 1. Those two multiplied together is just e to the x. So this is equal to x squared e to the x minus 2x e to the x minus the integral of e to the x. What's that going to be? Well, e to the x integrated is just e to the x. So minus 2 times minus e to the x is positive 2 e to the x plus c. Okay? So I'll start back from here. So minus 2 integral of e to the x. I'll start again. So minus 2 integration of x e to the x. This is another thing where two things are multiplied together. So we need to use by parts. One needs to be differentiated. One needs to be integrated. So the differential part is the power of x, so x. And the integrate bit is the e to the x. Sub all of that into your formula, work it out, and then your answer, we can factorise out an e to the x. There's our answer. Okay, and a nicer written solution for it. Okay, and as this guy says, write out your second integration separately. Yeah, you can if you want. He hasn't pulled the 2 out, which, yeah, doesn't really matter. Okay, one for you to try yourself. Okay, so pause the video, have a go. Okie dokie. So, integrate x squared sine x. So I'm going to go through this one dead quick. So integration by parts. There's your formula. Now we want to pick which one's u, which one's dv by dx. So u, this is sine x, this is x squared. Pick the polynomial term to be your thing you differentiate. So sine x is the one you integrate. So v is minus cos x. du dx is 2x. So the integral of x squared sine x is equal, oh, we need the dx, equals uv, so minus x squared cos x, and then we need to minus the integral of v du dx. So v du dx is going to be minus 2x cos x dx. This is equal to minus x squared cos x plus 2 lots of x cos x dx. Now we've got another integration by parts here, haven't we? It's two things multiplied together. So all over again, u equals dv by dx equals. Which one are we going to differentiate? Well, it's going to be the x, because it'll disappear. So v is equal to sine x. du is equal to 1. So this is all equal to minus x squared cos x plus 2 lots of uv x sine x minus the integral of v du dx. v du dx is just sine x. So our answer, minus x squared cos x plus 2x sine x minus sine x integrated. So sine x integrated is minus cos. So this integrated is minus cos. Minus and a minus make a plus, and we're multiplying it by 2. And then stick the plus c on the end. Okay, so there's the answer. Okay. Now, integrating natural log. As I said just, up to now, you haven't seen how to integrate a natural log. However, we know how to differentiate it. So, using by parts is a way of proving the integration of natural log. Okay, and this is a question that you can be asked straight up in an exam. Okay, prove the integral of natural log. Now, integration by parts, you need two things, don't you? A u and a dv by dx. Give me a sec whilst I write that. Okay, so we need a u and a dv dx. Here we've only got natural log of x. So as I've said, whenever you have a natural log, that's the thing that you're going to differentiate. However, we don't have a second thing to integrate. Or don't we? This is actually just the same as 1 times natural log of x, isn't it? So this question is just the same as integral of 1 times natural log of x. So we can just integrate 1. Okay, so now we've got the two things. So du by dx we can work out. V we can work out. So v is going to be x. Du by dx is 1 over x. So the integral of natural log of x dx is equal to uv, so x natural log of x, minus the integral of v du dx. So v du dx, x times 1 over x dx, x natural log of x minus the integral x times 1 over x is 1. So x natural log of x, integral of 1 is just x. So there's our answer. Okay. Now, definite integration, that just means that we've got limits. So same thing all over again, except between 1 and 2. However, we already have the answer to the integration. It's x natural log of x minus x. Okay, this plus c, you only need it if you don't have limits. Here we do, so we can just get rid of it. Okay, so it says here, leaving your answer in terms of natural logs. So you're not allowed to use a calculator realistically, and I'd say don't use one anyway because it makes mistakes. So, I've just literally, as I say, it makes mistakes, I make a mistake. So it's this when 2 is subbed in, take away when 1 is subbed in. Okay, now 2 natural log of 2 minus 1 natural log of 1 plus 1. The minus and the minus make a plus. Natural log of 1, if you try typing it in your calculator, the natural log of 1 is 0. So this is just 0. So our answer, 2 natural log of 2 minus 2 plus 1 is minus 1. So there's our answer. Okay. Now, if we was to have the limits at the start, all I would do is put the limits here. When you've worked out this part, just put the limits in here, and then here, and then at the end, I would then put the square brackets in. Okay. At this stage here, I wouldn't really bother with square brackets, just because this also needs to be within of the square brackets. Okay, neater version is there, and one for you to try yourself. Okay, I think this might be the same question as earlier, just with limits. If it isn't, then just do it anyway. So pause the video, have a go. Okie dokie. So I think the answer's on the next slide. Yep, there you go. So mark your work. If there are any questions, it's just the fact that the only bit that I think you'll get stuck on is this bit at the start. So x is the thing you differentiate, so x is u, sine x is the thing that you're going to integrate. Okay, carrying on. Now, the last thing for integration by parts. So it's two things multiplied together, isn't it? So it is integration by parts. Okay, but we need to decide which one to integrate and which one to differentiate. Okay, so which one shall we integrate, which one shall we differentiate? Neither of them are a natural log, and neither of them are actually x squared or x cubed. So it doesn't matter which one you pick. I'm going to go for, let's differentiate sine. I don't know why, but I'm just going to pick sine. Okay, so du by dx is cos x. V is going to be e to the x. So the integral of e to the x sine x dx is equal to uv, so ex sine x, uv that is, then minus the integral of v du dx, so v du dx, e to the x cos x. Okay, now here we've got almost an identical thing to our question, so we're going to have to use by parts all over again. Okay, This is two things multiplied together, so we need to use by parts. So here we need to choose which one's u, which one's dv dx. Now this one seems to work out quite nicely, so I'm going to differentiate cos this time as well. I've written that wrong. Okay, so we're going to integrate e to the x. So v is e to the x, du dx is minus sine x, cos x differentiated is minus sine x. So this will become e to the x sine x minus the answer to this thing, which is e to the x cos of x minus the integral of v du dx. So this things times together, so minus e to the x sine x dx. Let's expand the brackets just to make it look a bit nicer. So minus and a minus become a plus. So plus times another minus makes it minus. Okay. Now we've got here the question again, haven't we? This is, as it says in the title, a very nasty, weird one, okay, because you get the question back in your answer. Now there's a little trick you can do. On both sides you have the same thing, but this is a negative one, isn't it? So if you add this to both sides, you're going to get two lots of the question. Okay. So if you add this onto both sides, you just get two lots of the question. Now if you divide both sides by 2, you know the answer to the question is a half lots of this thing. Okay, I'm going to factorise out the e to the x at the same time. And there's your answer. Okay, so a weird one. That could appear on an exam. Here's a nicer version of the answer. As it says up here, this came up on an exam once. Okay, I remember the exam. Loads of people struggled with it. Yeah, so you need to understand this loop sort of idea, how you end up with the question in your answer. Okay, you need to understand this. Okay, so there we go. There's 11F done. Okay, we're now going on to partial fractions. This might be a new lesson, in which case, there you go, it's a new lesson. Just pause when I ask you to pause, please. Okay, so integration by partial fractions, probably one of the easier topics, just because you did partial fractions back in, I think it was year 1 or start of year 2, something like that. So if we were to just be given this integration, we could think, oh, because it hasn't got a power on the entire bottom, we could just write it as natural log as the answer. However, remember, if it's not just x, we need to divide by the differential. The differential of x squared minus 1 is 2x. So this would be reverse chain rule. However, x can be 0, can't it? Which means we're dividing by 0, which means that this not allowed. So we need another method. So partial fractions. Partial fractions is when you get a fraction and you split it into two different ones. Okay, now in order to split it into two different fractions, you need two you need a multiplication on the bottom of your fraction, don't you? Okay. Now, in most cases, it's just factorise the bottom, like this one. So if we factorise the bottom of that fraction, we're going to get x minus 1, x plus 1. Okay. Now, that, just use partial fractions on it. A lot of the time with these in exams, it actually gives you in part A a partial fractions question, and part B work out the answer to an integration using that part A answer. Okay, now partial fractions, a bit of a recap. When you have factorised the bottom of your fraction, those two things on the bottom of the fraction are two separate fractions in partial fractions. Okay. And then we need to work out the constants or the terms on top of the fractions themselves. Now, on the bottoms of all these fractions, we've got x minus 1 and x plus 1. So if we multiply both sides of this equation by x minus 1, x plus 1, all of the fractions will disappear. Okay, so this side, x minus 1, x plus 1, cancels out, so you get 2. A over x minus 1. X minus 1 will cancel with the x minus 1. However, you also are multiplying by x plus 1. So A is going to be multiplied by x plus 1 as well. Then same idea with the B. B over x plus 1. The x plus 1 will cancel. So you're left with the B lots of x minus 1. With partial fractions, there's multiple ways of answering this bit. However, I always think the easiest way is to let x be a value. So let's focus on this first one. If we wanted a to just disappear, we could let this equal to 0, couldn't we? So to let this equal 0, x would need to be minus 1, wouldn't it? In which case, the entire equation would become 2. 0 times a, so that just disappears, so 0a, plus minus 1 times b lots of minus 1 minus 1. So this is the same as 2 equals minus 2b. So b equals minus 1. Now we can do the same thing all over again. Let x equal a different value. So that time we let this one equal 0. So let's do it with this one instead. So for this to be 0, x has to be 1. So 2 equals a lots of 1 plus 1 plus 0 lots of b, because this is 0. So 2 equals 2a, so a equals 1. So partial fractions has now got us that 2 over x minus 1, x plus 1 is the same as 1 over x minus 1. B is minus 1, isn't it? So I'm going to bring the minus to the front of the fraction. And there's our answer to the partial fraction. Now, that's not actually answered the original question, has it? That's just done partial fractions. So let's go back to the original question. So this is equal to these partial fractions. So we can replace our original equation with this. Okay, just straight swap the original integrating factor with this. Now 1 over x minus 1. If the bottom was just x, the integral of 1 over x is just natural log, isn't it? Okay, but because it isn't just x, we need to divide by its differential. Okay, reverse chain rule. So divide by its differential is 1, isn't it? So divide by 1, you get the same thing. We've got a minus in between. 1 over x plus 1. Well, again, if this was 1 over x, it would be natural log. However, because it's not just x on the bottom, we need to divide by its differential. Its differential again is 1, so there you go. Okay, we haven't got limits, so we need a plus c. Now this, use your laws of logs. When you minus, you divide the things inside of your brackets. So there you go. Okay, now this is a little bit extra. C is just a constant, isn't it? So C, you could rewrite it, strictly speaking, as anything that you want. Now I'm going to say that C is the same as natural log of A. Okay, C is the natural log of A, and I'm just saying that it is. Okay, constant is equal to constant, it doesn't matter. However, here for this, we can then use natural logs again with it. Whoops, that's not a plus, that's a minus. Okay, so minus 1 over x plus 1 plus the natural log of A. So we can combine these yet again to say that it's A, lots of x minus 1 on the top, all over x plus 1 on the bottom. Okay? And then there is our final answer. Now, this answer here is completely fine. This one is just for in the cases where you're doing something else afterwards, basically. Okay, you'll see later on in the chapter, I think it's 11F, maybe even later than that, but this idea of changing your constant to another constant is very, very important. Okay, so there's a neater version of the answer. They haven't actually done the constant thing. That's why I was saying that it doesn't matter at the moment. Okay, so carrying on. Some more examples. So, partial fractions on this thing first. So, x minus 5 all over x plus 1, x minus 2. The bottom's already factorised, so we can just say that it's equal to a over the first part of the denominator plus b over the second part of the denominator. Multiply it all up, so x minus 5 equals a lots of x minus 2 plus b lots of x plus 1. Let x equal a certain value to try and get something equal to 0. So let's focus on this one first. What would x have to be to make this 0? 2. So 2 minus 5 equals 0 lots of a plus 3 lots of b. 2 minus 5 is 3, so 3 equals 3b, so b is equal to 1. Now let's let x equal something else to get the other thing equal to 0. So this one's equal 0 already done. This one equals 0, so x equals minus 1 to get this equal to 0. So minus 1 minus 5 is equal to minus 1 minus 2, which is minus 3 lots of a, and we've already said this second thing is equal to 0. Minus 1 minus 5 is minus 6, and that's equal to minus 3a, so a is equal to 2. Okay, so our original integration is equal to these partial fractions. So a is 2, so 2 over x plus 1 plus 1 over, because b is 1, x minus 2 dx. Now the 2 on the top is just multiplied by the fraction, really, isn't it? It's just the same as saying 2 times 1 over x plus 1. Now 1 over x plus 1, it's pretty similar to 1 over x, isn't it? 1 over x integrated is natural log of x. So this is just the same as natural log of x plus 1 with the 2 constant to the front. Check if you need to divide by its differential. Its differential is 1, isn't it? So if you divide this by 1, you should get the same thing. Same idea for the second one. The constant is just 1. So 1 over x. So if this was just 1 over x, that integrated is just natural log of x, isn't it? Because it's not just x, we need to divide by its differential. Its differential is just 1, so there's our partial answer. Okay, I'm not going to say that's the final answer, because in most cases it'll say write it in its simplest form. Now, simplest form, that means the fact of you need to use laws of logs. Now this is one law of log. When you've got a number in front of a log, you can bring it as a power. Okay, and then another one, when you've got a plus, you can actually multiply those two things together. Okay, and again, we could let C equal natural log of A or something, but I'm not going to bother doing that this time because I'm running out of space, to be honest with you. Okay, so another example. 8x squared minus 19x plus 1 all over 2x plus 1 x minus 2 squared. Now, partial fractions on this one. I'm going to write these two. However, hopefully some of you have already noticed, this one we're going to need a third fraction. Okay, this one we have the x squared on the bottom. We need a third one without the squared. Okay, when you have a bracket squared on the bottom of a fraction and you're doing partial fractions on it, you need to include both the squared version and a non-squared version. Okay, now multiplying that out, we're going to get 8x squared minus 19x plus 1 is equal to a x minus 2 squared plus b lots of 2x plus 1 plus c lots of, we're multiplying by 2x plus 1, aren't we? And there isn't one on the bottom of that, so that we're going to get the 2x plus 1 on the c. However, we're multiplying by x minus 2 squared. One of them will cancel, but we'll be left with the other one. Okay? Now, again, just partial fractions. So let's let x equal some values. So this one, if x is 2, a will disappear and c will disappear. So we'll just get b, won't we? So let's let x equal 2. So I'm going to grab my calculator just to speed this up. So 8 lots of 2 squared minus 19 lots of 2 plus 1 is equal to minus 5. We've got 0 a's. We're going to have a b, aren't we? 2 lots of 2 is 4 plus 1 is 5. So we've got 5b and we've got 0 c's, haven't we? So b is going to be minus 1. Let's let x equal something else. So we've let x equal 2, so this disappears. What if we let x equal minus a half? Okay, now the b's will disappear, the c will disappear, but we'll get an a, won't we? So I'm going to grab the calculator again. 8 lots of a half squared minus 19 lots of a half plus 1 equals minus 13 over 2. And then the a term, we've got, oh, I've made a mistake there, I just realised. This is actually 25 over 2. Okay, when you sub minus a half in, you'll get a plus here. I didn't put the plus. Okay, now here it's minus a half minus 2 squared. So minus a half minus 2 squared, that's the same as 25 over 4. So if you solve that, a is going to be minus 2. Now, we know what b is, we know what a is, however, we don't know what c is. This is where it starts to get nasty, okay? So, if we were to expand this entire right-hand side, so we've got 8x squared minus 19x plus 1 equals, a is minus 2, isn't it? So it's minus 2, expand the brackets, so x squared minus 4x plus 4. This one, just expand the brackets with b equal minus 1, so minus 2x minus 1 plus c lots of expand the brackets, so 2x squared plus 1 minus 4, so minus 3x, and then we've got a minus 2. Okay, so put that all out, so minus 2x squared plus 8x minus 8 minus 2x minus 1 plus 2cx squared minus 3cx minus 2c, and all of that's equal to 8x squared minus 19x plus 1. Now if you compare the x squared terms, you can see that 8 is equal to minus 2 plus 2c. Whoops. Okay, so 8 is equal to minus 2 plus 2c, which means that c is going to be 5. Okay, so that's one of the hardest partial fraction questions you could be asked, apart from the ones you'll see in a minute. Okay, so this integration is then going to be equal to minus 2 over 2x plus 1. Where's b? So we've got plus minus 1 all over x minus 2 squared. And then c is 5, so it's plus 5 all over x minus 2. Okay? Now these two things, they'll just be natural logs, won't they? This one, it's got a squared across the entire bottom of the fraction. So this one, if we write it as a negative power, we can just use reverse chain rule on it. Okay? So, let's start integrating. So I'm going to write that as actually minus x minus 2 to the power of minus 2. Okay, so this write it as a negative power. So now this integrated is going to be minus 2. As I've said, if it was 1 over x, it would be natural log, wouldn't it? However, it's not just natural log, it's 2x plus 1 on the bottom, so it needs to divide by its differential, which is 2. Now this second thing, if this bracket was just x, we'd increase the power by 1 and divide by the power, wouldn't we? So minus 2 increased by 1 is minus 1. So this minus, if you divide by minus 1, it'll become a plus. We'll keep the bracket, and the power just increases by 1. And then this last bit, the constant stays at the front. It's like 1 over x, isn't it? So it's going to be a natural log. If we divided by its differential, we'd just divide by 1 so it stays the same. Okay, then plus c on the end. Okay, so this is all just the same as minus natural log of 2x plus 1 plus 1 over x minus 2 plus 5 lots of x minus 2. Okay, now you could simplify all of this, so bring the 5 up to the power, put this underneath this because it's minus, yeah, divide them. However, I've run out of space and also the question didn't ask for it. So I'm not going to bother. Okay, but just know that you could. Okay, one for you to try yourself. So pause the video here for me, please, and have a go. Okie dokie. Answers are there. You'll have to zoom in. Okay, on the little controller, there's a little zoom in button. So just click that zoom in button, it'll zoom into the little parts. Okay, so one last part. So, top-heavy algebraic fractions. If I was to give you the fraction 3/2, you could tell me that's the same as 1.5, hopefully. Okay? With algebraic ones, it's the same idea, however you take notice of the powers. The top has got a power of 2, the bottom has got a power of 1, so it's top-heavy. Okay? So, the way to deal with it. Algebraic long division. Okay? We're dividing x squared by x plus 1. Okay? Now again, this is drawing on your previous knowledge. You need to know algebraic long division. X squared is just the same as x squared plus 0 plus 0. X squared divided by x is x. X times x is x squared. X times 1 is 1x. We take those things away. X squared take away x squared is 0. 0 take away 1 is minus 1x. Bring down the plus 0. Minus 1x divided by x is minus 1. And now minus 1 times by x is minus 1x. Minus 1 times 1 is minus 1. Take those two things away. Minus 1 take away minus 1 is 0. 0 take away minus 1 is 1. So x squared all over x plus 1 is the same as x minus 1 with a 1 remainder. So the 1 goes on top of the thing you're dividing by, and there you go. Okay? So the integral of this is the same as the integral of this. So when you integrate this, you'll just get x. X integrated is 1 over 2 x squared. Minus 1 integrated is minus x. Then 1 over x plus 1. It looks like 1 over x, doesn't it? So 1 over x integrated is a natural log. Divide by the differential, so that's your answer. Okay? Whoops. So, yeah, that's your answer. Okay? Now carrying on. Oh, there's the nice written answer. So, as I've said, when the top has got an equal or bigger power, okay, when the order, so the power of the top is equal or greater than the power of the bottom, you need to do algebraic division. Okay? So, have a go at those two for me, please. Use algebraic long division. Try and work out the answers, and I'll show you the answers in a second. So pause the video and have a go. Okie dokie. So answers are there. Okay, so use your algebraic long division to separate it into these two bits, and then you see that 1 integrated is x, 1 over x minus 1 integrated is natural log of x minus 1. Okay, and then there's 11g done. Okay, so that's it for now. I hope you have a good weekend, day, whenever you're seeing this video, and yeah, I hope I'll be in soon.